Okay, this is another one in a series of discussions how to manage using your calculator. And I've got right now a calculator with the program kind of already programmed in it. I'm going to show you what else is on that program, on that calculator. I'm going to clear here. I'm going to take a look around, for instance, see what are in my matrices. So in this matrix I have a 4 by 4 matrix in A, a 4 by 11, and a 4 by 11 in B and C. Now, for the most part, what we'll be seeing 4 by 4 matrices for is transformation matrices. So I'll point out how you can look at these. You can either just by looking at them by hitting enter here and looking at them that way, or you can go and do second matrix and you can go edit. Now some might recognize that, if you've been paying attention, that value as the cosine 0.66, not quite right, 0.669668, 0.959, I think, somewhere like the cosine. So let's just double check how we can put a value in there. We can just go ahead and put in the cosine of 15 degrees, plug it right in there, and we get, something might not be set correctly if I don't get something I recognize. So you can hit second quit here, turn on the calculator, check the mode. And pretty soon we'll be asking more than one question of what we want to ask it, more than one, but for now tangent of 45, of course, was our go-to. So we might want to say tangent of 45. And now that makes sense. So when I go here to second matrix and I go to edit, if I go down and I put in the cosine of 15, which we know is a small angle, should be about 15 times pi over 180, 0.2588. I must have hit the sign there, so I'm going to hit the cosine of 15 degrees is 0.97, 0.966. We can go minus the sine of 15 degrees. The sine of 15 degrees. You don't need to close your parentheses, but you probably should. The cosine of 15 degrees. Now again, it's all in there, and if you look at that matrix, you notice that the translation is all set to 0. You got some dummy ones around there, but you've got something that's locked up the z-axis and it's rotating about, so it's rotating about the z, so it's going to tend to rotate something. We can again, in the middle of mode, second quit, go back to mode, change it now to see a little bit better on the values. We try to put that 15 number in our heads. Second quit. Now you can go to second matrix. Remember, you have to actually select the matrix from inside these pull downs. You're not allowed to type in the bracket. So 0.9668.2558. Now we look at 0.9659 is the number we're going to stick on our heads. And you can investigate, that would be 1 minus theta squared to within 1%. At 14 degrees, the small angle approximation is off by 1%, at least according to Wikipedia. So you've got something in that matrix, and now let's look at what the other matrix might be. When you start to see something that's 4 long in a long series, there's a good chance it's a set of points with a dummy 1 in every column. So let's take a look at that. You can either go to edit, and you can see essentially a bunch of points here with a dummy 1. You can look at the dummy 1s going across the bottom. It's going to tell you generally that this matrix is probably a set of points, x, y, and z. That's how we have to deal with them when we're doing transformation. So let's take a look at what this program looks like and see if we can kind of make out, before we go to the discussion of what we did in class today, which was how to put in a simple work and torque program. So this one's a little bit more substantial. It's called DAR, and I'm going to edit it. Now, I'm going to work from the bottom up, pointing out that there's loops inside a loop. So every time you see an end, there's probably an if statement or a for statement or a while statement. So right now, this is going to for the number of columns in the matrix B, it's going to go ahead and draw lines between each point being a column. And if you notice there that B has both rows and columns, it could have actually, this only allows 2 by 2 or matrices in 2 dimensions. There are other matrices that are 3, 4, 5, and 6 dimensions. But in this case, you realize it is actually drawing a line. The command is in this program is line x comma y comma x comma y for the 2 points. So it's looped around. Prior to that, it's counted and figured out how big this dimension is, and taken the number of columns and then subtracted 1. And prior to that, it is looped through 24 times, rotating each time by the transformation matrix. So that's what's going on in this, and I'm going to put it up here one more time. You can then copy it, practice. I, J, and K are generally reserved for counters, but we can sometimes use them in other programs. You're going to clear what's on the drawing. You're going to multiply some matrices together, which you already have filled. Take the dimension of B and put it into list 1, and then take in the second value and put it into A, subtract 1 from A, and then loop through this line statement. That said, nothing is complete unless you've really set your window up. We'll see if that works. We've got some window x minimum, x maximum. You want to generally have the x to be 1.5 times the y. That's so you learn to draw a circle just like a circle. And now if you hit second quit here, if we now do program and run dar, we're going to run dar, and you see it's rotating that shape around a big circle. So, simple animation, that's all there is to it. You can do it with very extensive databases, because I'll hit second quit here. You can really put in as many points into one of these matrices as you want. Alright, so that is this one. What I'll show you now is how you could actually fill up a matrix, and I'll do the calculations of the program in another video. So, the best way probably to fill a matrix is to learn to put things into lists. So I'm going to just go ahead and show you how we can start with a matrix, a blank matrix, second matrix. We'll call matrix D blank, and do this. I can go ahead and open squiggles. I'm going to just all my points 1, 2, 3. I'm going to close squiggles, store it into second L1. Now what I can do is, for now, I can say second matrix math list to matrix second L1 comma second matrix, and I'll put it into D. So close parentheses, and now D is going to be just a matrix that's 3 by 1. So I can now, if I want, I could just add a whole bunch of ones, or I could change my L1. Let me change my L1. Second quit. Well, another way you can change besides doing things like I was showing you is go to the second list and go to list 1. See that there, but you can just go to stat is the way to do this. You can edit, and you can now make that perhaps 3, 4, 5. Second quit, and now you could do it this command, second matrix math augment second matrix D, and I think this will work, but it might not. Second list 1 close parentheses. Let's see whether that works, and it will not. So you would have to actually take L1 and stick it into a matrix E, and then make augment D with E. So let's try that. Second matrix math list to matrix second list 1 comma second matrix E. Alright, so you've done that. List one. Now you can do augment D with E. So second matrix math augment second matrix D, comma, second matrix E. Let's see if that actually just puts them together, or do you have to push them into a variable. So now you see second matrix. It hasn't changed, so what you got to do if you want to store it, you can go second math augment second matrix D, comma, second matrix E, close it, and then store into second matrix D. So what you've done is you put them together into D, and now you have second matrix D as a 3x2. So you could kind of continue to add columns as you go across, and in the end you could then do what would be a transpose that would make that 2x3, do an augment, and then flip back. Realizing that in the end you need to have 4 rows with the last row being a dummy one. Alright, so we've seen how, I'm going to hit second quit here, that we can kind of deal a little bit with lists. So I'm just going to go ahead and make a bunch of lists and put them into one matrix now. So I have second list 1, that looks legitimate. So I can now take second list 1 and store it into second list 2. I can say second list 1 and store it into second list 3. Second list 1, store it into second list 4. Second list 1, etc. Store it into second list 5, and finish up with second list 1, store it into second list 6. Alright, now what you've got, this would be a logical time. You'd probably have a bunch of lists. You could take second matrix math list to matrix second list 1, comma, second list 2, comma, second list 3. I guess we'll go with list 6, comma, second list 3, comma, second list 4, comma, second list 5, comma, etc. Second list 6, comma, second list 1. More or less you're just adding all kinds of lists, and then finally your final comma would be second matrix. I'll put this into the F matrix. Close parentheses, and now we've got the F matrix, second matrix F, that's a 3x8. So learning to kind of put points or vectors into lists and then stack them into a matrix is a good, reasonable thing. What we did in class, however, is also looked at you can take second list 1 plus second list 2, and you're going to get an answer, which makes adding of vectors possible. Second list 1 minus second list 2, and you'll get an answer for subtracting vectors. But when you take second list 1 times second list 2 and store it into second list 3, you don't really get much, though you get the work when you do this. Second list ops sum math, sum of second list 3, and that's how you get the dot product of two vectors. So the cross product is a little more extensive. I'll cover that in a separate video, but you would like to have an A work and an A torque and an A translate program in your calculator. Thanks for listening.